Example 16 looks identical to the previous two examples we've worked, and while the problem reads exactly the same, our approach is going to end up changing actually quite a bit from what we did in the last two examples. We're still looking for exactly 4 zeros, since this is a fourth degree polynomial. From there, we can look at applying the signs test. Looking at the original function, we see no sign changes, so we would expect 0 positive real zeros. And if we evaluate h of negative x, we'll get x to the fourth plus 170 x squared plus 169. We see no sign changes, so we still get, in this case, 0 negative real zeros. In the past two examples, we then would have gone on to look at rational zeros, which we could compose. We could look at our value for that constant and that coefficient for our leading term. But in this case, we just sort of need a little bit of intuition to understand that continuing in that approach would be a waste of time. Rational numbers are also real numbers, and we already know that we won't find any real zeros for this function based off the information from the signs test. So we need a slightly different approach for this problem. What we're going to do is look at making a substitution into our function, which will allow us to factor it and find real zeros using actually some simpler methods. This substitution step, though, can be a little bit confusing if it's something you haven't seen before. What we're going to do is let a new variable u equal x squared, which means that u squared will equal x to the fourth. So our function will now be in terms of u. So h of u in place of x to the fourth will be equal to u squared plus 170u plus 169. What we've done is essentially rewritten an equivalent problem that now looks like a quadratic function, which we can factor using some relatively simple factoring techniques. In this case, this would factor as u plus 169 times u plus 1. Once we have that expression factored, we can go ahead and substitute back in for u the expression x squared to get x squared plus 169 times x squared plus 1. We want to find all zeros for this function, meaning we want to solve when this function would be equal to 0. So we'll take x squared plus 169 set equal to 0 and x squared plus 1 set equal to 0 and solve both of those equations. This will give us x squared is equal to negative 169, or x is equal to plus or minus 13i after we take the square root of both sides. And with our other equation, we'll get x squared equals negative 1. So x will be equal to plus or minus 1 times I, or just plus or minus I. This means we have 4 complex zeros and no real zeros, which matches up with our expectations from the beginning of this problem. And we can write h of x in a fully factored form as x minus 13i times x plus 13i times x minus I times x plus I. Again, the key that we were looking for to take this approach as an alternative is that the signs test told us that there would be no real numbers that would be zeros for our function. Since there are no real zeros, we won't find any rational zeros. So even if we constructed that list of values for p and q, those values for p over q that we would plug in as test points, none of them would return a 0. The only way to get to our solution would be to use the substitution method and then factor as a quadratic function.